Okay, so we're moving on to the last section of Chapter 3. The last section is multiplication and division property, and it is probably the section that gives most students the most difficulty. So hang with me here. Okay, so I'm going to start with this example problem right here in the middle of the daily vitamin. So it says that this whole angle is congruent to this whole angle, and that these two angles, these two red angles, are both trisected. So you have angles that are trisected, which of course means that when you have angles that are trisected, these are all congruent to each other, and these are all congruent to each other. So because of that, and because that these big angles are congruent to each other, which breaks these into little congruent angles, hopefully you can see that all these little angles are all congruent to each other. And that's an example of division property. And so because of that, I know that if this is 3x plus 12 and this is 5x plus 12 plus 2, then I can say that 3x plus 12 must be equal to 5x plus 2, and I can solve for x. So when I solve for x there, x is just going to be equal to 5, and then I can plug it in to find the measure of angle BAC. So that's an example of what we call division property. So let's write out these multiplication and division properties, because for now, while we're in this chapter, and while I'm not convinced that you actually understand the multiplication and division property, I'm going to ask you to write it out. So multiplication property is when you have two congruent angles or segments. When those are multiplied by the same amount, okay, then you're going to end up resulting in congruent angles or segments. Okay, so if it doubles, those angles will be congruent to each other. If you have two congruent angles and you triple them, they're going to be congruent to each other, etc. Division property is basically if you have two congruent angles or segments and you divide them by the same amount, you're going to end up with congruent angles or segments. Okay, so this is what I'm going to ask you to write in the proof. I'm going to ask you to do that for a little while here. Now, when to use the multiplication or division property. So multiplication property is when you start small and you go to bigger congruent things. And when you're doing division property, when you start big and you are going to conclude that two smaller things are congruent to each other. Also, when you have two bisect or trisect or midpoint statements, and one congruent statement, okay, that's what you should be looking for in a proof. You should be looking for two bisect, trisect, or midpoint statements and one congruent statement. So here's what I mean by that. Let's try an actual proof down at the bottom here. Okay, so put some dots in here, some points. JE is congruent to SE. ER is congruent to EI. So hopefully you can see that JR is congruent to SI. And I know that I have two midpoint statements. I know that R is the midpoint of this segment up above, and I is the midpoint of that segment down below. And what I'm trying to conclude is that the entire length is congruent to the entire length. So you have to ask yourself, is that multiplication property or division property? It's getting bigger, so you know it's multiplication property. And I also can see that I have two midpoint statements, as well as I'm going to have a congruent statement. So let's write it out, and hopefully you'll see it. So JE is congruent to SE, ER is congruent to EI. Given. Step 2, JR is congruent to SI by addition property. Okay, that gives me my congruent statement. And then, whoops, step 3. I got my two midpoint statements, just given. So now, because I have a congruent statement and two midpoint statements, I can jump and say that JY is congruent to SN because of, and I'm going to use what we set up above for multiplication property. Let's say that if two congruent segments are multiplied by the same amount, in this case we're multiplying it by 2, by a factor of 2, then you're going to end up with congruent segments. Now I will point out to you that our book does add a little step in here that I am not going to require. In fact, I'm going to ask that you not write. And that is, the book says that you need a step where it's like a 3.5 step, where it says that JY is equal to 2 of JRs and SN is equal to 2 of SIs. Okay, does that make sense? You do not need to have that step in my class. All right, let's try a couple more problems on the back side. All right, we're on the back side of the 3.6 worksheet, multiplication and division property. And we're going to go after these proofs on the back side, just continuing work with multiplication and division. So angle 1 is congruent to angle 2 here, this first problem. Hopefully you can see just from that information that this is congruent to this. There's a couple of ways we can go after that. We can do sub-congruent angles are congruent, or we can do a subtraction property. And then it says that SC bisects those two. So I know that these two angles are bisected. And then 3 is congruent to 4. Hopefully you can see that that's going to be by division property, because we're going from a bigger set of congruent angles to a smaller set of congruent angles. Let's try this. So step 1, angle 1 is congruent to angle 2, given. Step 2, let's do a subtraction property. We haven't done it this way with straight angles, so we need to say that ESP and angle OPS are straight angles. That's going to be, I'm going to tell you it's going to be by assume from the diagram. Okay, you can say assume from diagram. And now I can say that those straight angles are congruent to each other. ESP is congruent to angle OPS, because straight angles are congruent. And now I can, from these two, I can say that angle ESN is congruent to angle NPO. And the nice thing is you can hopefully see that this is right here and here. Okay, those are the ones that we bisected. So in step 4, that's just by subtraction. Step 5, I'm going to have to throw these guys in there. Okay, and that's going to be my 2 bisects. Because ready again, we need 2 bisect statements, and we need a congruent statement. There's our congruent statement. So from that, I can say that, well, if these are congruent to each other and they're bisected, then the smaller pieces must be congruent to each other. So angle 3 is congruent to angle 4 by division property. Okay, and I need you to write that out. So it would be basically if 2 congruent angles are, then you have, are divided by same amount. In this case, it's divided by 2, then you have 2 congruent angles. Okay, now moving on to the next one. Oh boy, that looks tough. Let's see what we got here. KL bisects WD. So that gives me that these are congruent to each other, right? It's basically chopping WD in half. You have NI bisects ANW, so NI, so these are congruent to each other, and ES bisects, so these are congruent to each other. And you know that these are actually literally congruent to each other, so all these are congruent to each other. And we're trying to prove the triangle's congruent, so we're trying to get at these guys. I have to ask myself, all right, I need 3 pieces to prove those triangles congruent. I have 1. Looks like I have another one here. Let's try a different color. Another one right here is congruent to this one. Vertical angles. And I got a bunch of action going on with these guys here and here. And if I were able to get those 2 congruent to each other, then I could say that these are congruent. By subs of congruent angles are congruent, or by subtraction property we can try subs of congruent angles just for kicks. And it looks like I can prove these 2 congruent because I've got 2 bisect statements and a congruent statement right here. And so I can do multiplication property to get those 2 congruent. So let's write this. Step 1 right there, given. Step 2, I know that WR is congruent to RD. Segment bisector, give me 2 congruent segments. Step 3, looks like I can. Let's just get the vertical angles out of the way. Angle WRN is congruent to angle DRE. Vert angles are congruent. Okay, so that gives me a side, an angle, and I need one more piece. So now I'm going to go ahead and I'm going to do all these pieces right here as my givens, because I'm going to use those all together. Okay, once I have that, now I can say that angle WNR, the big angle, is congruent to LED. And remember, that was by multiplication property, and you have to write it out. Okay, and if you write it out, it's going to be if you have 2 congruent angles and they're multiplied by the same amount, then you have 2 congruent angles. now that I have those congruent to each other, let's say that angle WNR is supplementary to angle WNK, and angle RED is supplementary to angle LED. I think we said in the previous one, if you have straight angles and they're supplementary, we can assume straight angles. We don't need to write down that step. And now I can say that from these two steps right here combined, I can now get step 7 by saying that angle WNR is congruent to angle RED by subs of congruent angles are congruent. Okay, so that gives me my last angle right there. And so step 8, I can now say that triangle WNR is congruent to triangle DER. Wahoo, big moment. And that would be by angle, side, angle, side from steps 7, 2, and 3. And I'm done. I'm going to skip the problems down at the bottom and let you go ahead and just try some stuff on your own. All right, take care.